Hello everyone. In this discussion, we are going to have an interaction about design thinking towards mathematics. So mathematics, that is teaching mathematics. So I think you are aware of design thinking. What are the parts you have? What are the branches you have in design thinking?
Empathy, define, ideate, prototype, test.
So we have 5 concepts in this. Am I right? We have 5 concepts in this. So what is the first stage? Empathy is the first stage. Am I right? Empathy is the first stage. So let us connect with mathematics. So in mathematics, mathematics is the branch, is a kind of domain where we connect with lot of real-time situations. Okay, for example, there is a situation to solve a complex equation. For example, let us assume a differential equation, a complex differential equation. So we have to simplify that differential equation. So in order to simplify the differential equation, a researcher might be checking for a method. So it is his pain point, it is his requirement. So can we call it as an empathy? We can call it as an empathy. What is the second stage? So define. So that researcher is coming to the mathematician and he is asking for a concept. So sir, this is the situation. I have to solve this particular scenario. So do you have any idea for this? So as a mathematician, what I do, I will see what are the possible situations, what are the possible conditions, what are the possible alignments I could do in order to mathematically model that situation. So that is, I am defining that problem. I am trying to defining that problem. What is the next stage? Ideate. So once after defining that problem, so I am going to check what are all the mathematical ideas, mathematical methodologies I have, so that I can connect with that situation. For example, recently in our class we saw about solving differential equation using Laplace transform. So apart from Laplace transform, there are different scenarios, there are different areas, different ideas to solve differential equation. But I could say Laplace transform is one of the best tool. Laplace transform is one of the best tool to solve an ordinary differential equation. So maybe for a partial differential equation, the scenario may vary. There are various types of differential equations. So in that, ordinary differential equation, partial differential equation are the two main branches of differential equation. So to solve an ordinary differential equation, Laplace transform plays a wonderful role. And along with the differential equation, you might have some conditions. We can apply the conditions and we can solve. Also we saw, so in between the solving area, we used various techniques. For example, convolution concept or partial fraction or various results connected with Laplace transform. So here there is a merge of Laplace transform and inverse Laplace transform happens. Okay, what is the next one? Prototype. So once after defining the problem, once after finding an kind of analysis for that situation, so we go for a prototype. Okay, this is how I am going to plan. So I am going to take Laplace transform. So there are various methodologies. I am going to take Laplace transform because Laplace transform is rightly suited to this particular scenario, situation. Okay, so that is the prototype. So I am particularly selecting a methodology for this kind of this real-time problem that researcher have brought to me. Okay, that I could call as a prototype. So I have planned one, I have figured out one idea for this particular problem. What is the last stage? Testing. So once after understanding, okay, Laplace transform might be a good tool for this particular scenario, so I am going to apply it. So I am going to apply it and I am going to solve and I am going to get some solution for it. So that is called testing. Okay, that is called testing. So while solving we use a lot of implementations might be there, formulas might be there. We will be applying the relevant formula into that and we will be getting the solution. So that is called testing. So, okay, that was testing might give a positive result or a nearby result, or it may vary. So but we need a testing. But we need a testing in order to understand whether the prototype what we have generated, the concept what we have understood is rightly fitting with the problem. So whether it is rightly suitable for that problem. Okay. So this is how we work. This is how design thinking concept can be applied in mathematics. In particularly like mathematical modeling for real-time problems. So each and every scenario in our day-to-day life can be connected with mathematical ideas. So we call it as mathematical modeling. The type of methodology what we use may differ. according to the situation. We should apply a right technology. Okay. The next thing is design thinking idea. So design thinking idea can be split a partition like how we usually solve a mathematics problem. From defining the problem to getting the end result, we can exactly connect the design thinking idea. Okay. Is it clear?
Yes, sir.
Thank you.
Thank you.